Sequential control, commercial garage door. Sequential means the forming or following in a logical order or sequence. And when we apply this to electrical, to follow the sequential order in a schematic, an electrician must work slowly and methodically to identify the present state of all pilot devices, identify which loads are energized by the pilot device states, identify if energized loads, such as relay coils, will cause a change in state of contacts, and finally identify which loads are energized by those relay contacts. The whole process must be repeated multiple times as we work our way through a schematic system. One of the best types of schematics to utilize in a presentation such as this is a commercial garage door because of the use of different types of pilot devices that change state throughout the operation of the system. A commercial garage door like this will typically have a garage door opener that mounts on the side wall and looks something like these two items. We'll usually have a few cables coming down, one for power and one for the controls, which is typically an up, down, and stop push button station. There are many ways for commercial garage doors to be designed, and this is by no means meant to be a comprehensive listing of all the design specifications. The most basic requirements is you need an upper limit to stop the motor when the door is fully open, need a lower limit to stop the motor when the door is fully closed, and we need an emergency reversal if the door contacts an object prior to reaching the floor when closing. Now, a typical garage door in a commercial or industrial setting will not have big chunky limit switches like this, as they would be really challenging to actually mount on the wall and come into contact with the doors. It's not really feasible. Instead, we use a rotating worm gear and a fixed collar. And the fixed collars you can see right here, they're actually threaded nuts. And the nut is held from turning. Now, what that means is when this worm gear or threaded rod starts to turn, and because we've stopped this little threaded collar from turning, it will actually travel left and right on this threaded rod. Now, the rod turns when the motor turns and it's connected through a series of gears. And then what we do is we place micro switches or just small limit switches, which are inside the control cabinet, and they come into contact with these threaded collars. So what we can do is we can adjust where these collars are on the threaded rod and adjust the up limit and the down limit of a typical commercial garage door. Also, in commercial settings, a pressure bead is commonly used at the bottom edge of the door. And if a foreign object is impacted before the door is fully closed, the pressure increase will trigger the door to automatically reverse back to its fully open position. Now, these look a little different, and there's a number of different ways we can have them represented in a schematic, but this would be an example of one type of pressure switch with a normally closed and a normally open. And when it hits an object, obviously the state of those two contacts change. Now, it typically looks like this, where you have the pressure switch itself located on the wall, stationary, and the rubber seal on the vertical moving garage door. And then we have a small air tube that connects the two. Usually it's a black rubber coiled item that kind of looks like the old telephone wires. So we can have a schematic symbol of just a contact or the actual pressure switch itself. It really depends on the manufacturer. In residential settings, we have the same type of application. However, we usually use a beam or a laser beam, and when it senses an object in the path of the closing door, it will again automatically reverse back to its fully open position. So let's take a look at a pretty standard reversing motor starter that's used for a garage door opener in a commercial setting. We have a pendant start up, down, and stop push button station. We have a remote control or radio contact with a single button. And we have a safety edge, which is that pressure bead. And finally, we have limits, and this one's a bit unique in that it has also an auxiliary open limit switch. And we'll sort of see how that functions as we go through the system. So first, we're going to energize the system, and we're going to say the door is closed. Now, notice the position of the pilot devices. My safety edge is open. My open limit switch at the very top of the diagram is closed, and the closed limit switch is open. So that's at the very bottom of the diagram. So this means when the door is in its fully closed position, that limit switch opens. So let's go through the process. I'm going to press the open button down. And what that will do is it will energize the up coil. Now it will cause a change in state in the up contact, but also I want you to watch the closed limit switch. Notice that as the motor is running, the door is now moving. And because of that, the closed limit switch on the bottom closes. Now at the top, we still have a closed contact. It's the holding contact for the up circuit. I can then release the push button and the motor will continue to run until we reach the open limit or the fully open position, at which time you'll notice all of these limits will move at the same time. Now the door is fully open and my holding contact will then turn off or go back to its original state, and the door is open, nothing's going to happen. Well, let's say we want to now close the garage door. We're going to press the close button, and the close button then in the down direction is going to cause the down coil to energize, and the down coil energizing will cause the motor to start turning in the opposite direction. And again, I want to draw your attention to the holding contact as well as the pilot devices in the open limit section. They're going to change state at pretty much the same time. And this is because the door has now moved beyond its actual extreme open limit, and those limit switches have then gone back to their original or normal state. So now we have a holding contact that is in parallel with our start down push button. We can release the down push button and the door will continue to travel down until eventually we reach the closed limit, at which point the closed limit switch will open and the down will de-energize. And of course, the holding contact will go back to its original state. Now, what about that funny little radio button? Notice that it's only one button, and yet it says radio to open and to close. Well, the way that this works has to do with the auxiliary open limit switches. So at this point, the door is closed, so pressing the button has only one option. It will only open the door. And so when we press this button, it closes at contact, and that allows current to flow to the up coil and CR1. Now, once those two have energized, it's going to cause a change in state in a number of different places. I have the upholding circuit, I have the CR1 normally open contact, and I also have my CR1 contact at the bottom. They all change state at the same time. So notice the CR1 at the very bottom has now gone open. I've now got a closed limit switch because my door is now traveling up, and we can then remove our finger, presumably, from that radio button. All of this happens very, very quick. And we see that we have a holding path for both CR1 and the up coil in two different places. So again, the door will continue to operate until it reaches its open limit, at which point limit switch will open and all of the coils will then de-energize and the contacts that they control will go back to their normal state. Well, now the door is fully open. Let's use the remote again and press it and see what happens. At this point, when it's pressed, we see that there is now, due to the position of the limit switches, a path for current to flow from that radio open and close contact to the down coil. At this point, the down energizes and my down holding contact closes. And as this is occurring, we then run into a situation where the limit switches will eventually, for the up or the open portion, will go back to their original state. So now they actuate, and again, the motor is going to be traveling down until eventually we reach the ground and the closed limit switch will open, de-energizing the motor, and the holding contact will go back to its normal state. Now, what happens with this emergency reversal when we're closing it due to a foreign object? Like what? How does that work? So let's take a look. Let's say the motor's running in reverse right now, traveling down, and we encounter an object, and this object causes the pressure bead in the bottom edge of our garage door to actuate, and it closes this schematic symbol in our circuit diagram. So let's see what the implications of this are. It is going to energize the up and the CR1. Now, the up and the CR1 is going to cause a number of different things to happen, but notice up cannot close its contacts until down is de-energized, and that's due to the mechanical interlocking. Otherwise, we would get a line-to-line short circuit. So really the only contacts that can change state immediately are the CR1s. CR1s are now going to change state. And what this causes is a de-energization of the down direction of the motor. The motor stops. At the same time, we also have an energization of the upper section with the CR1 closed contact here. Current flows through, and we are now permitted. The up coil has been energized this whole time, but now it can operate because the mechanical interlocking has been disengaged due to the down coil de-energizing. At this point, now that up has energized or has been permitted to move the armature, the contact changes state and the motor will start turning in the other direction, placing the door into an up direction and going back to its original fully open state. Now the pressure switch will return to its normal state as we move up, but that won't make any difference to the operation of the motor, which will continue to operate until eventually we reach the top of the doorway and the open limit switch opens and de-energizes the circuit. So knowing what happens with all of these different pilot devices is extremely important. It's extremely important to be able to follow through a schematic for the full duration of its operation. And you need to be aware not only of how the system should operate, but also what the state of the different pilot devices will be due to their physical interaction in the system in the physical world.